Welcome to the class once again. I hope you are all doing good and in the best of your health. So after learning all the concepts of rotational motion and system of particles, I believe that you will be ready to practice question based upon JEE Advanced pattern exercise. Now in JEE Advanced examination, I have regularly told you the question will be single choice, more than one option correct, assertion reason type, integer type and matrix match type questions will be asked. In our exercise, we will try to practice single choice, more than one choice, assertion reason and integer type. And I want you all do see the various illustrations also from your textbook also. So without taking more time, let's go ahead with the first question of the day. The first question comes here. It's a single choice question. A small mass m is attached to a massless string whose other end is fixed at P. So we can see that a small mass m is attached with a point P as shown in figure. The mass is undergoing circular motion in the xy plane. So we can see that this is the z axis and this is the xy plane about which this mass is actually performing the rotational motion or circular motion. You can see that circular motion in the xy plane with center at O. This is the center at O of the circular motion and constant angular speed omega, that is the angular speed omega does not vary, it remains constant. See the statement, its speed omega remains constant angular speed omega. If the angular momentum of the system calculated about O and P are denoted by L0 and LP. That is, angular momentum about point O is L0 and angular momentum about point P is LP respectively, then option number A, L0 and LP do not vary with time, first option. B, L0 varies with time while LP remains constant. C, L0 remains constant while LP varies with time. D, L0 and LP both vary with time. Now, how to do such kind of questions? It's not too tough for us to understand. First of all, let me tell you, this question has been asked in one of the JEE examination. It's a quite good question, tricky question. Actually, this actually entails us how to evaluate the angular momentum. Now, before proceeding with the solution part, let me tell you, any body performing circular motion, its angular momentum can be evaluated as, it's given as r cross P. This is what we know, r cross P, where P is the linear momentum. So we can write it as m r cross v. P is equals to mass into velocity. We have taken mass, the constant outside, and r, both the r and v vector, v are vectors, so we can write in this way. Now, first of all, we will apply this equation. You see that this body is performing a circular motion about this point O. This string is here, this string is attached in this way. It's a case of pendulum, you can think in this way, a conical pendulum, you can think in this way. Now, as this is revolving, let me show you its path. This, I believe that this diagram would be making quite more things clear to you all. This is the point O, the center of the circular path about which it is actually rotating. This is the point P. Now see here, as it is rotating, I want you all to simultaneously imagine with me the scenario. This is revolving. Now first of all, let me talk about point O. So if I talk about point O, the motion will be somewhat like this. This is point O, the particle is actually revolving. So for about this point O, this radius r, its magnitude will always remain the same. As it is moving, this is the linear velocity v. Try to understand. Now, if you do r cross v in this two-dimensional figure, in the figure you imagine on the plane of the board, r cross v will always come out of the plane of the board. That is, it is perpendicular to this line that I have drawn, both r and v. It is perpendicular, it is coming out of the plane of the board. At any point of its motion, when the particle reaches here, the velocity reaches here. You see here again, this is the r vector. If you perform r cross v, again you will be getting r cross v, its direction vector will be coming out of the plane of the board. Direction is always out of the plane of the board. Now in this case here, try to understand, its angular velocity is omega in this way, it's revolving in this way, okay. That means if you perform r cross p, its linear velocity will be going into the plane of the board. If you perform r cross v, the vector, resultant vector will point upwards, that is L0 is directed upwards. The angular velocity is constant, that is not varying. Hence, we can write that the L naught value as mv into r, and since angle between r and v is 90 degrees, so mvr sine 90, that will turn out to be mvr. First of all, what does this imply mvr? V will remain constant, speed will remain constant, linear speed, r is constant, mass is constant. That means the magnitude of L naught will also be constant. Its direction every time is constant. That means L naught will remain constant with time, it will not vary. So first thing we can mark out, first thing let me write, L naught remains constant both in magnitude and direction. So we can say that it's constant, it's not varying. Now the main important part is about LP, that is the angular momentum about point P. This is the most important point. How to understand it? Imagine you have to use your imagination. You see here, this is the line PO, this is the O connecting with the particle, this is line P connecting with the particle, this is string. If we talk about its angular momentum about point P, you see here, its linear velocity is going into the plane of the board at this point. Its linear velocity is going into the plane of the board. This is the r vector here in this case. So let me extend it. Let me say this is r vector. So let me use r dash vector, that will be far better. Or let's say its length is L. So let us use this as L vector. That will be more better to actually differentiate between r that we have used in this case and L we are using for this vector. Now you understand L vector is pointing along this direction. V velocity is pointing, you see here, this is the line that's coming down. V is going into the plane of the board here in this way. If you perform the cross product of this vector with this vector, you will get your thumb pointing this way. So let me show you, this is pointing somewhere here, or let me rub this part. At this moment, this is the direction of LP vector. At this moment, you have to understand this. At this moment, this vector will be pointing somewhere here. At any other situation, at any different situation, you see if the particle reaches here, understand, its linear velocity will be here. The line connecting P with the particle will be somewhere here, its linear velocity is here. If you do L cross P, your thumb is pointing towards this side. That means the angular momentum direction will be somewhere new, and let me show you. For this position, it will be somewhere here, LP, the new case. What we are finding, LP direction is changing regularly. For different situations, the LP direction is changing. But let us talk about the magnitude. Again, L and V both are perpendicular to each other. You can clearly see that L and V are perpendicular to each other. Its magnitude will remain the same. If I talk about magnitude of LP, that will be equal to magnitude of ML multiplied with V. This is what we will be getting. Magnitude will remain the same. So for LP we are having magnitude remains constant but direction varies. Magnitude remains constant but direction varies. So if direction varies, what can we make out from it? That means the entire vector is changing. It is variable in nature. It's not constant, it's not fixed, it's variable in nature. That means LP varies with time. LP vector varies with time. It is not constant. See actually what happens, what the examiner checks. Examiner checks from you all actually how better and deep understanding you have of the concept. It's a very simple concept. Right now on my explanation, you've understood that how simply we have solved this compared L0 and LP, whether they are varying or whether they are constant. But on the day of your examination, let me tell you, you will be actually troubled with finding out the direction. If you've solved many questions on the direction of angular momentum, you can clearly take less time in solving such kind of questions. This is one of the previous JEE examination question. So now you can understand what kind of questions the examiner is interested in asking from you. They are not seeking from you tough calculations, they are not seeking from you quite elaborated questions, they are only seeking from you the better and deep understanding of the concept. How better you have worked on yourself to actually enhance your ability. That is what the examiner is seeking from you. So if you know each of the concept, you can actually answer them very well in less time and correctly also. This question, let me tell you, right now you'll be thinking that it's easy and simple, but on the day of exam, if you solve it on your own, you'll find that on the first go, you'll find it difficult to actually make an approach. But if you approach it in this way, you are going to find that it's easy and you can solve it. So we found that L0 is constant, LP varies since LP direction varies. So we know that a vector's direction varies, the vector will not remain constant, it will be a variable vector. Let's check the option. L0 and LP do not vary with time. No, LP varies, so this is incorrect. L0 varies with time, L0 is constant, so incorrect. L0 remains constant, yes, L0 remains constant while LP varies with time. Yes, this is what we have evaluated. Option number C, L0 remains constant while LP varies with time. D, L0 and LP both vary with time. No, L0 is constant, both do not vary with time, so D will be incorrect. Only C is the correct option here. This was a very good question. I hope that you understood how to solve such kind of wonderful questions on the day of your examination. Do practice, you'll find that your efficiency will enhance and your accuracy will automatically be augmented and automatically the speed will be also increased. Let's go ahead with the next question of the day. Question number 2. Again, this is a previous year question. Consider a body shown in figure consisting of two identical balls. We have one ball, another ball, two balls, each of mass capital M connected by a light rigid rod. This is a light rigid rod. If an impulse J equals to mv, J equals to mv, you can see that the impulse J equals to mv is imparted to the body at one of its end. Rod, two bodies, at one of its end, we have an impulse provided to this body. What would be its angular velocity? For the entire system, we have to find out what its angular velocity. A v by L, B 2v by L, C v by 3L, D v by 4L. Rod of length L, mass M, we have an linear momentum J equals to mv. That means an impulse J equals to mv is imparted to it. Now try to understand how to solve such kind of question. If linear impulse is imparted, that will give an angular impulse to the entire body. I will tell you how to solve it. Since it's a rod, don't think that it's a thread. It's a rod. We have one body of mass m connected with a rigid rod to another body of mass m. Here to this we have given an impulse J equals to mv. Let us say this is the center of the rod. So what will happen? Try to understand. A rod you have fixed, you just push it from here, so it will rotate through its center. You can understand it will rotate through its center. That is, this entire system will rotate about its center with some angular velocity, let's say omega. And we need to find out what would be its angular velocity. For the entire system, what is the angular velocity we need to find out. Now from the concept of angular impulse, you see here, if linear impulse has been imparted. So about this point O, what is the angular impulse? So about point O, angular impulse imparted will be equal to angular impulse. That will be equal to, if we write angular impulse, that will come out to be linear impulse into distance, that is J into L by 2, that will come out to be mv into L by 2. mv into L by 2, because this distance will be equal to L by 2, hence we can write in this way, mv into L by 2, we got the angular impulse. Now from the concept of angular impulse will be equal to the angular momentum provided to the body. The body comprises of this mass and this mass. So if they are turning with angular velocity omega, so angular momentum, since they are moving with angular velocity omega, angular momentum of the body will turn out to be, we know that angular momentum is equal to I into omega. I will be m into L by 2 whole square for this and m into L by 2 whole square for this. So we can write I net multiplied with omega, because omega is same. I net will be ml by 2 whole square plus ml by 2 whole square. So 2 ml by 2 whole square. I hope you have got why I have written this. this is only equal to moment of inertia of the entire system. We have two masses, m into L by 2 whole square, m into L by 2 whole square. So m into L by 2 whole square and multiply by 2, multiply with omega. This should be equal to angular impulse. So let's equate it to angular impulse that already we have evaluated. So hence we can write angular impulse that we have evaluated, that is equal to mvl by 2. So mv L by 2 is equal to, let us write down, 2m L square by 4 multiplied with omega. Clearly you can see that what things will be cancelled out. We can easily cancel out the given terms. This 2 will cancel out 2 times, so this 2 and 2, then 2 will be cancelled out, and this now again you will be having one term that will be cancelled out. Omega will come out to be, this L and this L cancels out, omega comes out to be, and M cancels out, V by L. Omega comes out to V by L, that easily we can identify from the given set of solution that we have reached. From the each step we proceeded, in this way you have to proceed. Again in this question, what problem you will face during the starting, as you read the question, you will the problem face, you will think that how it will rotate. Whether you will, the second mistake, or the common mistake that a student can do in, if he tries to do the question in haste, he will think that it's a thread, only this body is moving and this body will remain constant. No, both the bodies will be moving. Just try to imagine a rod. If you push it, see, entire body will rotate. If it's kept here, entire body will rotate in this way. So if it rotates, that means both the objects placed here and here will be rotating. You can clearly see that. So if it rotates, that means how it will be having an angular momentum. An angular momentum that will be provided by the angular impulse, and it's rotating about the center that we have marked. So you have to find out the angular impulse imparted by this linear momentum given to the body. That will be actually mv into L by 2. Equate it to the angular momentum, I into omega, I net into omega, and I will be used for both the particles about this center O of the rigid rod. This is how you have to approach. This is how you have to solve such kind of question. Good question, let me tell you. This has been asked in one of the previous year JEE examination. So I believe that now you will be mentally preparing yourself what kind of questions do come in your JEE examination. Let's go ahead with the next question of the day. Question number 3. A particle of mass m is projected with a velocity v making an angle of 45 degree with the horizontal. The magnitude of the angular momentum of the projectile about the point of projection when the particle is at its maximum height h is a 0, b mv cube upon 4 root 2 g, c mv cube upon root 2 g, and d m into root 2 g h cube. All these options have been given to us. Now let's check which of the option is the right answer. First of all, you see that it's a case of projectile motion projected at an angle of 45 degree. One statement. Next thing, it says that you have to find out with the magnitude of angular momentum of the projectile. You have to find out the angular momentum of the projectile about the point of projection. About the point of projection when the particle is at its maximum height. These are the important points of the in the given question. Let us mark what thing is happening. Let me tell you. Let's say this is the axis that I have just made. Let's say this is the projectile that has been fired. Now we are interested in maximum height and point of projection. See, the velocity given to is v here, and this is projected at an angle of 45 degree. So let us show that it's projected at 45 degree. Now let's talk about the maximum height. Let's say this is point A, in case of maximum height. This height is h max. Now you see here, at the highest point, the velocity will be somewhere here, and that will be equal to v cos 45 degree. That will be equal to v cos 45 degree because horizontal velocity never changes. That is equal to v by root 2. Once again, you have it, the statement particle of mass m is projected with a velocity v. So hence we have used the velocity v with which it was projected, and here it will be having only velocity, that is horizontal velocity. Now it is given that you have to find out the angular momentum about the point of projection, about this point we have to find out the angular momentum. Let me join this. Let me extend this. So we are interested in finding out the angular momentum. This angle, let's say it's alpha. I hope that you can clearly see this angle is alpha that has been given. Now this is the length vector. Try to understand, this will be the length vector. Let's say this is the length vector, or let's say this is the r vector. Now if I try to find out the angular momentum about this point, because we are interested in finding out the angular momentum of the body about the highest point will be given as r cross p, that is equal to m r cross v. R cross v, that is rv sine alpha, that will become, so r, now this, if this is alpha, so hence this will be angle alpha, r sine alpha will be h max, that is mrv sine alpha, and r sine alpha is h max, so mv into h max. This is the final equation that we will be actually resolving to find out the magnitude of the angular momentum. Now mv into h max, how to find out mv into h max? H max, it will be equal to, since it is projected at an angle of 45 degree, we all know that the formula for maximum height is v square multiplied with sine square theta upon 2g. This is what the formula that we have to use. So this will come out to be v square sine square 45 degree divided by 2g. For sine 45 degree is 1 by root 2. So if you do square, it will become 1 by 2. So you will be getting v square by 4g. This will be the value of h max. Clearly now multiply here. You will get the answer, now multiply here. So you will be having mv into h max. This is what you have to do. So finally, to find out the angular momentum of the particle at the highest point. Now one more thing, we are writing this velocity v, that is the highest point velocity. I have mentioned mrv. So let us, because we have used v for initial velocity, let's use this as v dash. That will be better, because v dash will be equal to v by root 2, that will be using v dash. Let's use it as v dash, the particle's velocity at the highest point. This is equal to v dash. Next thing, let's put up the value. So we'll be having L, that will come out to be m into v dash into h max that we have written. Let's write down m. Now v dash equal to v by root 2, v by root 2 multiplied with v square by 4g. So this will come out to be mv cube upon 4 root 2g. So finally let me write down the answer somewhere here. mv cube upon 4 root 2g. We got this mv cube upon 4 root 2g. This is the value of angular momentum in this case. Let's check the option. mv cube upon 4 root 2g, that is option number B. A incorrect, C incorrect, D incorrect. Quite good question. I hope that you have understood how to solve this question, and H will not be there in our given option. Good question. This has been asked in one of the previous JEE examination. I hope that you have understood how to find the angular momentum in various cases. With this question, it will be elaborated in case of projectile motion about various points, how to find the value of angular momentum. Next question of the day, and I hope that all these three questions would be very much helpful for you all. Fourth question, next question of the class, question number 4. A sphere is rolling without slipping on a fixed horizontal plane surface. So we can see that it's a case of a sphere. In the figure, A is the point of contact, B is the center of the sphere, and C is its topmost point. Then we have to actually check VC minus VA equals to twice of VB minus VC, B VC minus VB equals to VB minus VA, C VC minus VA is equal to VB minus VC, its modulus, both we have, and modulus V minus VC minus VA equals to 4 times of VB. Now see here how to solve such kind of questions. First of all, let me tell you, this case is not of a ring, it's a case of a sphere. all the particles are located on the various points of the spherical surface. A is the bottommost point, B is the center, C is the topmost point. So we have to relate all the three velocities in this case. Let's go ahead, let's see how we can actually proceed with such kind of question. Already we know the case of a ring, we have discussed already, the case of case of a ring. What about sphere? What about sphere in this case? Let's discuss about the case of sphere. Again, the 3 points that we have marked on its surface, point A, point B and point C. We have 3 points. Recall the case of ring. Try to connect it from there. And let's say how we can find out the velocity of each of the points on the sphere. We have, let's say it's rotating with an angular velocity omega. It will be having a linear velocity, let's say v. V will be equal to r into omega. In this case, linear velocity, the point B is having linear velocity v. Now, the bottommost point, its velocity, we know that that is 0. So, need not to worry about it. So, velocity of A, let's mark it as 0. Velocity of B, that is equal to v, and it is towards right hand side. We are taking the right hand side as positive, left hand side automatically will become negative. Vc, that will be equal to twice of v, again towards the right hand side, that clearly we can make out. This will be twice of b, this will be only v. First option, let's check Vc minus Va equals twice of Vb minus Vc. Vc minus Va, Vc minus Va, Vc minus Va, you are going to get Vc minus Va will get you 2v, and let's check twice of Vb minus Vc. Twice of Vb minus Vc. Vb minus Vc will give you minus v into 2, you will get minus twice of v. The magnitude is same in both the cases, but their direction are different, and here you see we have to show them vectorially. Their direction are different, so they will be incorrect. It's not a right option, it's an incorrect option. This is how you have to proceed. Option number B, Vc minus Vb. So let's check option number B. Already we can check it here. Option number B we have, first of all, with left hand side we have Vc minus Vb. So Vc minus Vb will clearly give you V, and we have Vb minus Va. Vb minus Va, it will also give you V. Quite clear to us, both are actually resembling and both are same. So hence option number B will be correct. See, option B will be correct. Let's say here B is correct. Now it's a one single choice question, so need not to worry about the next two options, but let's check for our satisfaction what about the next two options. Modulus of Vc minus Va. Modulus of Vc minus Va, if you do here, you have Vc minus Va equals to this. Its modulus will turn out to be, need not to worry about the direction, only magnitude 2v, and we have modulus of Vb minus Vc. Modulus of Vb minus Vc, that will turn out to be Vb minus Vc. In vectorial form it will be minus v, but only vector form it will be v. Both are not matching. So option number C is again incorrect. Option number D, Vc minus Va, its modulus. Vc minus Va is modulus 2v, already we have taken down. That is equal to 4 times of Vb modulus. That is 4 times of Vb will give you 4v. So if I write 4 times of modulus of Vb will give you 4v. Hence incorrect. This is not matching. So D is also incorrect. I hope that now I have got how to solve such kind of question. Option B will be only correct answer. Rest all options will be incorrect. Quite good question, and this question has been asked. So if you know how to relate the velocities, we have discussed how to find out the velocities for various points on a solid object when it is in pure rolling motion. We have discussed only this were 3 simple points given on the sphere. The thing that has been changed, it's not a case of ring, it's a case of sphere. Let's proceed with the next question, the question number 5. We have, A particle of mass m is projected from the ground with an initial speed u0 at an angle alpha with the horizontal. At the highest point of its trajectory, don't think that it's this is at the highest point of its trajectory, it makes a completely inelastic collision. So see here, it's a perfectly inelastic collision with another identical particle. So identical particle means mass will be same, which was thrown vertically. Identical particle mass same, thrown vertically upward from the ground with the same initial speed u0. Both the particles are having the same initial speed u0. The angle that the composite system, when they strike, they will become one composite system, makes with the horizontal immediately after the collision is made with the horizontal immediately after the collision is made. Okay. So for this statement has been actually repeated, but don't worry, after the collision that has been made. It's A pi by 4, B pi by 4 plus alpha, C pi by 4 minus alpha, and D pi by 2. Let's check which option suits here, and I will tell you how the scenario you can understand. We have one particle is projected at an angle alpha. See here, this particle is projected making an angle alpha. First thing, it will move in a projectile motion. So let me show you, this is the case of a projectile motion, and it lands here. This is how you can understand. Now from here, another particle is projected, same mass with same speed u0, it's projected. Both are going to collide. At the highest point of the first particle, whose mass is given as m, see here, this is the first particle, its mass is m, this mass is also m. Let me mark that it is the first particle, it is the second particle. For the first particle, the only velocity it will be having, that will be, it's projected if with speed u, you can see that projected from the ground with an initial speed u0 at an angle alpha. So it will be having only velocity u0 cos alpha along the horizontal. For this body, if it is projected with speed u0, if it hits, its speed will become v. We can already evaluate by knowing this maximum height formula, h max. We need to find out, now see, what angle, now they become a composite body, they will fly off together. As they fly off, they will move together, let's say making an angle theta, and let's say this is a composite body, so its mass will be 2m, with some velocity it will actually fly off. One thing we know, before the collision and just after the collision, there is no external agent that is actually applying any force on them. So we can say that the linear momentum will remain conserved. Linear momentum, because in the case of collision, before the collision, after the collision, will remain conserved. You see here, if I talk about the horizontal momentum, that will be due to this body. If I talk about vertical momentum, that will be due to this body. So we will be having at highest point momentum will remain conserved before the collision and after collision. Momentum before collision will be equal to momentum after collision. Momentum before collision is equal to momentum, MOM I am writing, that is for momentum after collision. Clearly you can write each of the momentum before and after. You see, before, its momentum is m u0 cos alpha along x axis. So m u0 cos alpha I cap. Its velocity is v along this direction, so m into v j cap plus m into v j cap. V we can write in u0 form, that I will tell you, is equal to final momentum, that is 2m, and we don't know about the velocity, we will just write here 2m into its velocity v cap. We need to write down this thing, that we will be trying to understand how it will be actually the final velocity will be, or let me keep it as it is, momentum final of the body of mass 2m. Now see here how to evaluate this. It's a case of inelastic collision. What is the value of v? V will be equal to, you see here it's projected, it travels at height h. So V, if we evaluate here, we can use V square is equal to u naught whole square minus 2gh. H again we can use the value of h as, because h is the maximum height, minus 2g, and the value of maximum height in this case will be u naught whole square sine square alpha divided by 2g. This is what we can use. So this will come out to be u naught whole square minus u naught square sine square alpha. So because 2g will be cancelled out. So we will be having, this will be u naught whole square minus u naught whole square sine square alpha. So u naught whole square, you take common 1 minus sine square alpha. We will be getting u naught whole square cos square alpha. I believe that you would have got how we have reached to this value of v square. So if I write the value of v, that will be u naught cos alpha. If I write the value of v, that will be u naught cos alpha. I believe that that's clear to everyone. Let's see here, let's put up here. So we'll be having mu naught cos alpha I cap plus m u naught cos alpha j cap, because v is u naught cos alpha, so we are putting instead of v as mu naught u naught cos alpha, is equal to final momentum. Clearly if you see, this is the final momentum. So I cap says what is the momentum along the x axis, j cap says what is the momentum along the y axis. You see that both the coefficient of I cap and j cap are same. That's for a vector. If its I cap and j cap coefficient are same, that means the vector is making an angle of 45 degree with the x axis and 45 degree with the y axis. We need to find out, the system makes the horizontal we need to find out after the collision, we have to find out what angle, the angle that the composite system makes with the horizontal immediately after the collision. Clearly this value, which both are same, that says that it will make an angle of 45 degree. So 45 degree is the right answer. So pi by 4 will be the right answer. Rest, this is incorrect, incorrect, incorrect. Alpha has got no role to play. The answer will be pi by 4. I hope that this exercise would be very much helpful for you all in your understanding of the concept and understanding what kind of questions are asked in JEE Advanced examination. I want that you all practice more questions to have perfection in yourself, and I'll meet you all with some more concepts in the next class. Thank you everyone, wish you all the very best.